Hello, everybody. Happy summer. This is CSC 225 calling data structures. Now, you'll find that the Sakai site has been published, and all that's there at this point is the syllabus. There are some interesting things on the syllabus. For example, we're not going to have tests. So everything's going to be based on your labs and your projects. Now, this course is a very important course in computing. It's one of those, the concepts we use here are everywhere. Almost any kind of area you go into, operating systems, networks, artificial intelligence, you have to organize the data. And they all use the structures that come from data structures. Also, I've been reading on the web that when people do technical interviews for computer science jobs, some of the questions come from data structures. So pay attention. Now, the first question I think we always have to ask is, what are we talking about? So what is a data structure? And I'm not going to try to get technical. I don't think there's any reasonable technical definition. A data structure is a format for organizing, processing, retrieving, and storing data. I better pull that out a little if I can. Well, there we are. Now, that being said, you already know a lot of data structures. Int, char, bool, arrays, vectors, strings. All those are data structures. The first three are simple data structures. The arrays, the vectors, and the strings are more compound data structures, more complicated. We have used various techniques to create more complicated structures already. For example, struct creates records. Which we can view as a collection of fields. An example would be the struct address. And it might have string, first name, mid, and L name. So it has three fields in it, and they're all together. And this is really what we're talking about. We're talking about bringing things together. However, this kind of a structure here is, we're going to contrast it in a minute with classes. And one of the textbooks I was looking at, this is a passive structure. It's used, it creates things for us, but we don't see any methods. It is possible to define methods, but people don't usually do that. When people want to create data structures, every language has some way to do it. The one that you're used to is the class. In a class, we can have fields and methods. And remember, methods is a fancy name for functions. Now, that's more active. We are going to do things with the particular object that we're working with. When we talk about this way, an instance of a class is an object. For example, if we had a class student, then the line student Mary and Matilda would define two objects. And let me put this back. Would define two objects that are student type. Now, other languages will have different names for these things, but the ideas are more or less the same. Since we're dealing with objects, we are really getting into an area called object-oriented programming style, or OOPS. You remember how computer scientists love to come up with acronyms and strange names. This one's been used in every possible way you can think of. But it's very important. It's the way many people program today. It's how we do it. The idea is that a programmer should think in terms of the objects of his problem, and not have to dwell in the messy details. When I have an object, if I want to print it or write it, I should be able to say the name of the object .print. I shouldn't have to worry about going in and taking care of all the pieces of it to print. When I want to take an object, if I have an object that has an array in it, if I want to print out the array or see the array, I should be able to use some kind of method that usually we call a get. So the idea is to elevate the way we are thinking about our problems. Now, this leads to the concept that is also rather important, in fact very important, the idea of data abstraction. The programs you've written are usually small, but real-world programs are not small. They can be thousands, millions of lines of code. And we want to separate in that code the problem part, the user, the way the user is going to use something, and the way it's going to be implemented. Now, this would mean that you would implement something once and then you'd reuse it. For example, if you're going to use a tree, you'd write out all the methods for a tree. You'd have a class that's called tree, and then you'd put it away, and every time you needed a tree in a program, that was there. You'd have the implementation of it. So what we're trying to do is we are hiding the implementation from the user. We're telling the user, here's the words you can use. Don't worry about how it's done. This way, we could change the implementation. There'd be no reason why we couldn't. If we found a better one, or we had a different way of doing something, we could do it. Now, you've seen a little of this. Think of the public versus private parts of a class. The public parts are the face of the class, the way the user looks at it. The logical way to look at it is another way of saying it. The private parts are the implementation. Ideally, you're not supposed to have to go in there. You don't need to know that a fraction is a numerator over a denominator. When you want to write a fraction, you shouldn't have to write the two separate pieces. So basically, we've been doing some of this. By the way, I should tell you the technical difference between a struct and a class. I checked this on the web. In a struct, all items are public unless defined otherwise. In a class, all items are private unless defined otherwise. Now, we don't really need to worry too much about that. We use structs to put together records that are going to go into classes usually. And when I want to do an abstract data type, I'm going to do it with a class. And that brings up one of the major words and concepts we'll be using all semester, and that's the idea of an abstract data type. So an abstract data type, which is always abbreviated ADT, is a structure. So it's the first the structure, where the properties of it are independent of the implementation. So you don't have to worry about the details of how it's done. It's just there. We can find it.